Sometimes, at night, I can still hear the torch. But I love the smell of flux in the morning. It smells like failure. Because you see, the internet experts are all going to have their opinions. But if you haven't been in this particular foxhole, then you don't know. You don't know. Sprocket, I'm trying to do a thing here. Never mind. This is going to be stupid anyway. Hello Internet, my name is Quinn, and this is Blondihacks. Well, this is not the video I thought I was going to make this week. They say you learn the most from your failures, and if that's true, I'm going to learn a lot in this video. Yes, it's silver soldering time for my boiler project, and I'm going to tell you right now, it failed. Now, I'm going to show you all the things that I tried, all the steps that I went through, and my plans for recovering from this failure. So, I think you're still going to learn a lot if you're interested in silver soldering your own boiler, but just understand that there is not yet a working boiler at the end of this road, but there will be one at the end of this journey. So let's go. Here's my shiny, freshly fabricated copper boiler, all ready for silver soldering. Now, for silver soldering large model boilers like this, there are basically two schools of thought. On one extreme, we have the Alex Weiss method, which is to set up the entire thing, fixture all the joints in place, flux everything, apply solder to every single joint, and then heat up the entire boiler all at once. On the other extreme, we have the Kozo-Hiraoka method, which is to go one joint at a time, very meticulously one by one. Conventional wisdom says that shouldn't work because you risk remelting old joints every time you heat up the next one, but in fact Kozo's method actually does seem to work for him very, very well. Now in my case, I'm going with the Alex Weiss method, mostly because I learned about Kozo's method halfway through this process, and you'll see me change strategy here along the way. This is actually my second large model boiler. The first one was a much simpler pot boiler, and I did have success on that one, but I made lots of mistakes there as well. Now rest assured, I make all new mistakes on this boiler. So the first step is to dismantle everything so that I can flux the joints and clean everything up. Silver soldering is about three things: clearances, cleanliness, flux, and heat. Wait, is that 5 things? Anyway, it's about some very important things. On the cleanliness front, you will need a pickle bath. So I've got Sparex number 2 here, which is a common pickling acid. People also use 10% sulfuric acid for this. Sparex is a little easier to get and a little cheaper, and it works just fine. So I've got enough here for 2 gallons, which is enough for my boiler. The general rule of thumb is you always want to add acid to water, not water to acid. I don't know if it matters for this Sparex, it's pretty mild stuff, but nevertheless, I will do it this way. So pour that stuff in there and then just stir it up until it's nice and evenly mixed. Note that my stir stick is brass. One thing about Sparex is you're not supposed to put anything ferrous in it. It will contaminate the acid. Next I set up my hearth. Now this is actually a really poor hearth setup, and I'll explain why here in a moment. Next, I cut a piece of round ceramic fiber board. This ceramic board is great for silver soldering fixturing because it's immune to heat pretty much, and you can cut it easily into different shapes. You can score it and snap it, or you can hacksaw it or whatever. So I'm making this round piece to fit inside the tube sheet, and that's going to hold the tubes in place vertically when I flip the boiler over, just to make sure that the tubes don't fall through if the silver solder happens to remelt. The silver solder that I'm using is Harris Safety Silv 56. This is a cadmium-free low-temperature silver solder. So it melts at about 1200 degrees, perfect for this application, and I'm using their accompanying white flux. A quick sidebar on silver solder, because I think a lot of people from outside the model engineering world aren't very familiar with this stuff or why we use it. Now, all solder is technically a form of brazing. It's a chemical bond between dissimilar metals, but silver solder is closer to what you think of with brazing. So it's a very high silver content form of solder that melts at a high temperature. So it's typically got somewhere between 40 and 60% silver, compared to electrical or plumbing solders, which are considered soft solders, and they typically melt at a much lower temperature. Now, silver solder is important for boilers because not only is it very, very strong, it's actually stronger than the copper around it when properly used. It also remains flexible, so it can handle the expansion and contraction and shifting and so on that boilers do during their lives. Now, don't confuse this with so-called high-temperature plumbing solders. These have like 7% silver in them, and they are still considered soft solders and definitely not safe for boilers. I'm preparing my silver solder now, so I'm making rings to go around the tube sheet joints, and then I also made little rings to go around all the tubes. Now, a quicker way to do this is just to wrap a coil around one tube and then cut them into rings, but I did it the stupid way because at the time I didn't know about the other method. And note that I'm also using 1/32 silver solder here, which is already a mistake. I should have been using 1/16 silver solder, the little thicker stuff. Before silver soldering, the complex parts all go in the pickle bath, which is a chemical cleaning. Cleanliness is absolutely critical for silver soldering. Everything has to be spotlessly clean. You can do chemical cleaning or mechanical cleaning. So for the shell, I just ran the drum sander in there and did a nice mechanical cleaning on that. And the little studs that support the plates went into a little bit of pickling acid as well. After 5 minutes in the acid, everything is thoroughly rinsed in clean water, and then I apply flux to both sides of every joint. So there's the tube sheets on both sides, and then I can slide the tube sheets into place there. And then those little studs, you may recall, hold them suspended in space in the right positions. So I slide that down there. Now obviously some of the flux is going to get rubbed off in this process, but it's okay, it'll mostly still stay there. The studs get dipped in flux and threaded in. It's important that the silver solder flow all the way around those studs as well, or they will be leaks. The silver solder will follow the heat and also the flux to some degree, so it's also important. Same thing on the bottom, and then I'm also just fluxing the outsides of the joints again. When the flux melts, it'll tend to run into the joints as well, so that'll help. Now on the subject of fire tubes, there are other methods people use for sealing those, including swedging and flaring and rolling. Almost none of those methods are going to be approved though by a model club boiler inspector, and they're not typically done by model engineers. Silver solder is the method of choice. It's not to say some of those other methods don't work in certain situations. Tube rolling, for example, is used on model locomotives, but it does require a lot of skill and very expensive specialized equipment to do that properly. And again, if you don't really know what you're doing, you're probably not going to get certified doing that. And if you use one of the simpler mechanical methods like swedging or flaring, you do still have to use a caulking of some sort, which is often soft solder. And again, that's not considered safe for long-term use in model boilers. So silver soldering is by far the easiest way to get a result that is safe and will stand the test of time. And that's how model engineers have been doing it for a long, long time. And I'm fairly new to this, so I don't know enough to question established practice. So I'm going to do it the way people say you should do it. And then flux all the tube holes and the outsides of the tubes as well, of course. And remember that the tops of the tubes are slightly flared so that they will be held in place. And then I put a little ring of silver solder around each tube and then slide the tubes into place. And then the same process for the boiler bushings. And remember, I made a fixture plate to hold these at the right spacing and to keep them square to each other. Now this is again the Alex Weiss method, which is different than the Kozo method. Kozo would have soldered these bushings in place by themselves first and then did the next series of joints, whereas Alex has you do all of this stuff all at once in one giant heating. And the fixture plates are tied in with titanium wire, as I described last time, and then of course a ring of solder goes around those bushings as well. And then those big rings of solder go around the tube sheets. Now the solder's only been applied to the top tube sheet for now because you always want to have gravity working in your favor when you do this. Now the big moment, the actual heating. If you do everything right, the actual heating only takes a few minutes and it just works and you're done. The prep is by far the most effort. However, I am not doing it right and I'm doing a whole bunch of stuff wrong here already. So let's talk about that. First of all, I'm using oxyacetylene with a rosebud tip. Oxyacetylene is not a good choice for silver soldering large model boilers for the simple reason that what you need is not actually peak temperature, which is where acetylene really excels. What you need is volume of heat. You need to heat the entire boiler up all at once. Acetylene is a poor choice for large volume heating jobs like this because of the 1/7 rule of acetylene, or what's actually now more commonly used is the 1/10 rule. It's a little more conservative. The rule says it's not safe to extract more than 10% of the weight of the tank in an hour. If you do, what happens is you start drawing acetone out of the bottom of the tank. Acetone is added to acetylene to stabilize it. So if you draw that acetone out, the acetylene gets less stable and the tank starts to get dangerous. So that's obviously very, very bad. Acetylene is also expensive and you're going to need a lot of it to heat up a boiler this big. It's hard to appreciate if you've never done this job how much heat a boiler like this can shed. Like, it's incredible. Even acetylene has trouble adding heat to a 4-inch copper boiler faster than that copper can shed it. It really is quite amazing. Which brings me to the next big mistake I'm making here, and that's my hearth. This is woefully inadequate. It's not enough to just have some fire brick around the boiler. You have to really make a cocoon of fire brick, or refractory brick is even better. Something to insulate the process and really keep that heat in. Otherwise, again, you're just wasting fuel and you'll never get that boiler hot enough fast enough. Because you have to get the boiler hot within about 5 minutes, because the flux has an effectiveness window that the silver solder has to melt within. If you sit there heating for too long, the flux will spoil. The last thing I'll call out here is you see me doing some heating from above on the tube sheets, which is really not ideal. One of the key tenets of silver soldering is that you have to heat the metal, not the solder. The metal has to melt the solder because the solder follows the heat. Just like electrical soldering, you should never touch the heat source to the solder itself. You're not going to get a good joint doing that. However, with the Alex White's method on a fire tube boiler, you really don't have any choice for part of the tube sheets. You can't reach the insides of them. So this is what I was doing, but more on that here in a little bit. But basically, you just heat the whole boiler until all the silver solder flashes shiny and chrome. Make sure to witness those joints to ensure their passage into Valhalla. What a lovely day. When you're done, the boiler will look a frightful mess. It'll be charred and black and flux residue everywhere. So let it cool down most of the way, and then back into the pickle bath it goes for another 5 minutes. And then drain all that acid out of the inside of it there. And then you can rinse it off in clean water. And the pickle is really quite amazing. It'll remove all that ugliness from the torch. All of that black char and everything just wipes right off. Flux residue is dissolved. It'll come out kind of a dull pink color because you're basically doing a very fine etch on the copper. Not enough to remove any real material. You don't have to worry about safety from pickling many times. But the boiler will clean up very nicely after this. And then you can buff it back to its original shine from here if you want. After the first big heating, it actually looked pretty good. This is basically what you want your joints to look like. There's a ring of solder around each tube and all the way around the outside. There's a little fillet, and there's no obvious flaws there. The underside is a little messier. I did struggle with the underside because it's hard to get the torch down inside the firebox there. So it's messy, but we'll see if those joints are any good. And then I had some issues with some of the studs here. One of them fell out, and one of them looks like it didn't get silver solder all the way through. But we can hopefully address those issues. I am going to file these studs off now because we shouldn't need them anymore. And that's really what they should look like. You can see the solder penetrated all the way through, and then the stud can be filed smooth, and it's like they were never there. Well, nervous moment, time for the first pressure test. So I put Loctite 545 on all of the plugs and plug off all of the bushings. And then I put my hydrostatic test pump on one of the bushings. One of the top bushings is left open so the air has somewhere to go, and I pump the boiler full. And then when the water is right up to the top, then I put that last plug in. The goal is to get all the air out of it if at all possible. And well, I didn't even make it that far. The boiler is not even watertight. Now, that's actually okay. I've read a lot of boiler build logs in the last 6 months, and I can tell you that the boiler not being watertight right off the bat is not uncommon, and certainly doesn't mean the boiler is no good. Now this moment right here is where a generous viewer had sent me Kozo's book, The Pensy A3 Switcher, which has his incredible treatise on silver soldering in the back of it, and I learned his method, and it sounds great, so I switched to using his method. So you can see I've got a proper hearth now, fully encasing the boiler, and I've got the Sievert propane torch that everybody recommends for this, including Kozo. And this is an incredible torch. Now, it's Swedish made. There is a US distributor for it called Best Materials, but otherwise they're a little bit hard to get in the US, but definitely worth the effort to get one. It does not use oxygen, just regular old barbecue propane tank, and it's plenty hot enough for silver soldering. You really don't need an oxygenated flame for this, which is nice because it also means you can wear regular safety glasses. You don't need the Shade 5 infrared protection like you do for oxyacetylene. Now, OSHA does technically recommend Shade 2 glasses for regular propane torches, but, you know, make your own judgments on that. So at this point I've switched to Kozo-san's method, and I'm heating one joint at a time, making little repairs on the leaks. I'm heating the top tube sheet joint here because there was a leak there. The green flames that you see, incidentally, are the pickling acid burning off. I didn't do a very good job of getting all the acid out of the inside of the boiler, but that's harmless enough. I am wearing a respirator. I always do for torch operations because you never know what kind of weird gases are coming off of it. Now, the whole boiler will be black from the propane torch because it is a very dirty flame since there's no oxygenation. But that's okay. Once again, the pickling acid takes all of that off. With that sievert torch and a proper hearth setup, heating up that joint only takes 1 or 2 minutes, which is about what you want. Any faster than a minute is probably too fast. You're probably stressing the joints. And longer than 5 minutes, and you've probably spoiled the flux. Another pressure test verified that that top joint was fixed, so I switched to the bottom joint. Now this one was much more of a mess. There was some silver solder in there that hadn't flowed properly, so I got on there with some sanding and grinding tools and did my best to clean out the crud. Usually after that grinding, you can actually see the flaw. So there you can see that's the pinhole right there after a little bit of sanding. Not always, sometimes a perfect looking joint will still leak, but it builds confidence when you can actually find the flaw like that. For every repair you attempt, you always have to pickle beforehand and then reflux and then reapply solder. Everything's always got to be clean. So here's another view of the process here. So the repair area is pointed downward, so gravity is working in my favor. And that sievert torch is doing its magic, and you can see the silver solder flashes into the joint when it gets to just the right temperature. As soon as you see that silver solder flow, you move the torch away, and job done. And you can see how the flux has cleaned the area. All the pink area there is where the flux did its magic. The flux keeps the torch from dirtying the area during the process and ensures a good joint. Another pickle and rinse and another pressure test, and I found another leak, this time on a boiler bushing. So once again, I've got a good hearth setup here, I've got the right torch, and I'm heating the metal around the bushing, not on the bushing itself, to make sure the metal melts the solder. And once again, that looks like a good joint, and after pickling, that's looking very fine indeed. So at this point, things are going quite well. I'm fixing one joint on each heating, just like Kozo says, and the boiler is getting better every time. So at this point, now I'm down to the tubes. Everything else is sound. And so on this pressure test, I'm actually starting to build some pressure now, which is looking pretty good. So I'm marking problem areas with red Sharpie and continuing to build pressure. Now at its peak, I got to about 110 PSI and I had one remaining seeping tube. Things were really looking good. I've fixed a couple other tubes already, as you can see from the extra silver solder around, and I've got this one last tube that's seeping. Got one little pinhole right there. And otherwise the boiler is holding 110 PSI, just 10 PSI short of my goal. I was getting excited, so I made this last repair, and well, this is where it all started to go wrong. After fixing that tube, I had created 2 new leaks. And I thought, well, that's odd, but you can see here how this old joint, which was perfect, is now cracked, and that was leaking. So I fixed that tube. And then I had another leak. And then I had another leak. And then I decided to go nuclear, and I reapplied solder to several leaking tubes, refluxed the whole tube sheet, reheated the whole thing, reflowed all of the solder, which took quite a bit of heat, because once silver solder has flowed once, it takes more heat to get it to flow a second time, because it oxidizes and it kind of cures, if you will. And basically the entire tube sheet got covered in silver solder because of all the repairs I'd made, and reflowing everything kind of spreads it out real thin. And doing that fixed 4 leaks. So I thought, okay, I'm back on the road to success again. At this point I theorized that repairing a tube was heating the adjacent tubes excessively and causing those joints to fail. So I tried a different strategy. I did a general heating with the propane, got the whole thing pretty close to silver solder temperature, and then switched to my small acetylene brazing tip, and then just got in there like surgically. This torch is like a scalpel, so I can get in there and apply heat just where I need it. And the idea was the whole thing is close to silver solder temp, and I just need to add a little bit of heat right in the area around that joint to melt the one joint I'm trying to repair. This, however, just doesn't work because copper is, as I said, so incredibly good at shedding heat. It actually sheds the heat faster than the acetylene can put the heat in, at least with this small brazing tip. So short of a big rosebud, the acetylene just cannot get the heat into that thing fast enough. So in this case, I had to switch back to the propane to finish the job, and once again heated up the whole tube sheet, and once again I created a couple of new tube failures. I tried all different methods of shielding the other tubes, and I tried cooling them down as slowly as possible with insulation and all sorts of things. I couldn't find any way to repair a tube that didn't cause another tube to fail. So this boiler was just about done. Just before I gave up, I decided to try the last refuge of the boiler making scoundrel, and that's the tube swagers. So I've got a swager and a flaring tool here. So the tubes that are leaking, I tried swaging them. The squeezy style worked well on the top. The lower tube sheet I couldn't reach with the squeezy style, so I had to use the hammering style, which requires supporting the tube from underneath so I don't bend the tube sheets in this process. And it does risk bending the tube internally, but a little bit of that is okay probably. And that does actually work to some degree. I did fix a couple of tube leaks doing that. I don't know how safe those repairs are, but it did fix some leaks. However, there was a couple that couldn't be fixed, and you can see that all the hammering and heating and everything has distorted the tubes and the tube sheets, and I just could never get ahead of the leaks. And at this point, I'm in about 6 weeks of time spent just trying to fix leaks every evening after work and every weekend, and I just couldn't get ahead of it. So at some point, you got to call it. I decided to cut this boiler apart and start over. I want to cut this apart in a way that preserves the joints so I can inspect them from the inside and see what went wrong. So I'm going to start by cutting the firebox off. This will actually be reusable on the next boiler. The firebox is where most of the machining time was in the shell, so it'll be definitely worth saving this. So I'm going to do my best to cut this off cleanly and squarely here on the horizontal bandsaw. And bittersweet Yahtzee. That leaves just a pressure vessel, and the pressure vessel is symmetrical now, which is what I want for the next boiler because, as you recall, it was quite difficult to silver solder up inside the firebox. Now, to get the tube sheets out, I decided to drill them out. I considered trying to trepan them out on the lathe or setting up the rotary table and milling them out. The problem is that the shell is not very round from all of my hammering and heating and so on, and copper is really ornery to mill, and I wasn't looking forward to that. These tube sheets are pretty thick, so I just set it up on the drill press and chain drilled it out. I did one lap with a 1/4-inch drill and then a smaller drill for some of the tighter areas, and then I finished up with a cold chisel to knock out all the remaining material there. This went very quickly. This only took maybe 20 minutes to run the drill press around there, and it preserved all the joints for inspection. So mission accomplished here, I think. The core took a little bit of persuasion to get out of there because some of those tubes were a little bent from my ham-fisted swaging efforts, but out comes the core, which bears a striking resemblance to some piece of a nuclear reactor. The first look at the insides of the tube joints is very educational. So in general, those joints are excellent. That's exactly what the tube joints are supposed to look like. The solder flowed through. There's a nice fillet on the back sides of all of them. Everything looks great, except look very closely and you can see these hairline cracks. If it weren't for those cracks, these joints would be perfect. So at some point in their lives, these joints were good, and then these cracks formed. So probably that's when things started to go downhill with my repair efforts, is I was starting to crack those joints on the back. And those are not going to be fixable from outside the boiler. Once you get those cracks on the backs of the joints, you're done. The tube sheet joints look good. It's hard to show on camera with the copper carnage that's in there, but silver solder flowed all the way through. No issues there. Not surprising, the tube sheet joints are pretty easy to do. Now, I struggled to keep the boiler bushings from leaking on the top, and you can see why. On this one, I got very poor penetration of silver solder. Almost none made it down there, so that was never going to seal. On the other one, it's a little better. I did get some silver solder through the joint, but you can see a gap there, and that gap is right where there was a leak that I was fighting. So again, that was probably never going to be fixable from above. So cutting this thing apart really was the right move. At this point, it probably was not fixable. Now I'm going to cut one of the tube sheets off here just to get a better look at some of those internal joints. The horizontal bandsaw made mostly quick work of that, but towards the center there, it was really starting to trap the blade. So I switched to the hacksaw and a little bit of persuasion with extreme prejudice, and off it comes. So now we can see all of the joints, and yeah, the story is the same in here. These joints were all perfect at some point in their life, but they pretty much all have fine hairline cracks in them that were never going to be fixable. One crazy thing here on this tube, you can see there's a massive waterfall of silver solder on this particular tube. I'm not exactly sure what happened there, but clearly that was, again, one of my ham-fisted repair efforts. I must have opened up that joint at some point and silver solder just ran down there like water. So yeah, I was using a lot of silver solder trying to repair this thing, and well, now I know where it all went. All the repair efforts and deconstruction have left basically all the components badly distorted, as you can see on many axes. So nothing except the firebox is going to get reused in the next boiler, but none of this copper will go to waste. It'll all be useful for something. It'll go in the stockpile. The old shell is too out of round to reuse. What I will probably do is split it lengthwise and anneal it and unroll it and make a nice big piece of copper plate out of it, which will be very useful for future projects. Failure is only failure if you don't learn from it. If you do learn from it, then it's just a step along the way. So given what I've learned here, the rebuild will be different. For starters, I'm going to simplify the geometry. It will be fewer tubes of larger diameter, so it'll have comparable surface area, but be a much simpler structure to build. And I'll be building the tube sheet and fire tube core as a separate assembly with high temperature silver solder. And then I can heat the joints from below, as is good practice, and I can possibly even pressure test the core separately. Then I can slide the whole thing into the shell, solder that up with lower temperature silver solder, and those tube sheet joints are easy to do from the outside. So I think all of that will greatly increase my chances of success the next time around. Now, the bigger a failure I show on my channel, the more unsolicited advice I get from commenters who've never actually done this job. So all I ask is that you please be humble and understand that just because you work on air conditioning cores or you've built brake systems for cars that seem to have similar structures to this, doesn't mean you actually understand all the challenges here. And on that note, I want to really thank and shout out the Chasky Home Machinist Forum. The boiler making experts over there gave me a lot of great advice and were really supportive and helped me make a plan for moving forward on this project. So I'll link to them below. Big thanks also to my patrons who got to see all 6 weeks of the ups and downs on this in gory detail and provided much emotional support. And if you'd like to be one of those patrons, you can use that card there at the end of the video and help out the channel. I got a lot of copper to buy now, and the patrons are really what keep this channel going. Thanks for watching, and I'll see you next time.